Okay, so we are currently working through patterns and graphs. So first things first, list the next three terms, okay? If you are not sure what the word terms mean, it's just basically that is a term, that's a term, that's a term. So each number that is separated by a comma is its own term. So when they say they want the next three terms, they just want to know what would go there, what would go there, and what would go there. So in order for me to do that, I first need to figure out, how am I getting from 8 to 20? Oh, I'm adding 12. How am I going from 20 to 32? Oh, I'm adding 12. So how am I going to get to my next option? I'm going to add 12. So if I go 32 plus 12, that gives me 44. That's that one over there. Now, how do I get to the next one? I have to add 12. So if I add on 12, it gives me 56. And then if I add on 12 again, it's going to get me to 68. So they just want the next three numbers in the sequence. That's just what terms mean, okay? So next one over here, question B is the exact same, okay? Let me figure out how am I going from this to this. I am minusing 4. So I'm just going to minus 4 again. So 2 minus 4 is minus 2. I'm going to do it again, which is minus 2 minus another 4 is minus 6. And minus another 4 is going to give me minus 10. So remember they want the next 3. That's why I did 3, because they wanted 3. Okay, now list the first 3 terms using the rule 5n plus 1. Okay, all I'm going to do is, I'm going to ask myself, if this was a 1 for term number 1, what would my answer be? So it would be 5 times 1 is 5, and 5 plus 2 is 7. That is term number 1. Term number 2, I just plug in a 2. So 5 times 2 is 10, and 10 plus 2 is 12. That is term number 2. Next one, because I need the first 3 terms. What are the first 3 numbers? So then I put in a 3. 5 times 3 is 15, and 15 plus 2 is 17. And that is my first 3 terms. Okay, let's do the next one. Now it's a little bit more tricky because you've got some bigger numbers. But I'm allowed to use a calculator, so we can do that too. If I need to do the first 3 terms using this rule, okay, I'm taking out the letter, I'm putting in the number. So how many terms do they want? They want term 1, they want term 2, and they want term 3. So if I need to know what term 1 is, I just take out the letter and put the 1. So 100 minus whatever 3 times 1 is. And 3 times 1 is 3. So 100 minus 3 is 97. Now I need term 2. So 100 minus whatever 3 times 2 is. So 100 minus 6 is going to give me 94. Third one. Because I want term number 3, I'm putting in the number 3 instead of the n. So 100 minus 3 times by 3 would be 100 minus 9, which would give me 91. And you'll notice I am subtracting 3 each time, which is the same as that. Okay? Next one. List the first 3 terms using this rule. We're going to do the same thing. Same rules apply. We need to figure out what is going to be on term 1, what's going to be term 2, and what's going to be term 3. And all I do is I take the letter out and I plug the number in. So for this, I'll show you how to do it in your calculator. So we have got n to the power of 2. So instead of an n, I'm going to put a 1 in brackets, and I'm going to press that little button to get me a squared. Okay, and what's next? So I've done that. I've done the 1 plus 10. And I'll just plug that in. And that gives me 11. Next one. I'm looking for term number 2. So I need to take out the letter N and put in the number 2. So I plug in a 2, the power of 2. So everything stays the same. I'm still putting in the power of 2. I'm still adding 10. I'm going to get to 14. Let me do the last one, which is going to be plugging in a 3, because they're asking about the first 3 terms and I'm on the third term. So 3 to the power of 2 plus 10 gives me 19. So all I did, if you look at my calculator, I just plugged in a 1 for when I needed term number 1. If they want the first 3 terms, they want term 1, which is just the first number. Then they want term 2, which is just the second number. Then they want term 3, which is just the third number. So all I do is I take out the letter and I put in the number 1 to find what will number 1 be, term 1. What will the second one be? I put in a 2. What would the third one be? I put in a 3. Okay. Now, let's move on to write down the rule. So they could ask you, write down the rule, write down the formula. They could even ask you, what's the equation? It all means the same thing. Now, the first thing I'm going to do is, I'm going to do exactly what I did up here. This exact same step, I just figure out how am I getting from one to the next. So, how am I getting from 3 to 11? I'm adding on. What am I adding on? 8. Yeah. So 3 plus 8 gives me 11. Let's just double check that works. 11 plus 8 will give me 19. That does work. So whatever I'm going up in, I'm going to write down and I'm going to plug the letter N right next door. Right next door, that letter N is going next to that number. Now the next little part is I just need to figure out what would come before. So if I had to go backwards, what would come before the 3? And I can do this just by doing the opposite. So if you really want to use your calculator, I would just go 3. And this is plus 8, so I'm just going to do the opposite, which is minus 8. And that gives me minus 5. And I just write that down. But then look here. A lot of students mix these two numbers around. A lot of students mix those up. Your first step should always be, how am I getting from 3 to 11? How am I getting from 11 to 19? What number is that? Write it down and stick an end to it. That should always be your first step. Okay, let's look at the next one. For me to get from minus 2 to 2, I'm adding 4. For me to get from 2 to 6, I'm adding 4. So I'm taking that number and I'm immediately sticking the letter N next door. Then I'm going to ask myself, what would come before? So again, if you want to use your calculator, minus 2, let me do the opposite. So if that's a plus 4, I'm just going to just minus 4. And that gives me minus 6. Okay, question H. Write down the rule for 60, 45, 30. So for me to get from 60 to 45, I'm taking away 15. For me to get from 45 to 30, I'm taking away 15. Immediately, I take that whole number and I stick an N next door to it. Then I've got to ask myself, what would come in front or before 60? So I know that this number is going to be bigger than 60 because if you notice, that's getting bigger. So I would add on 15 to get me positive 75. So So the number, notice how the number in front of the n is what we're going up in or down in. 4, I'm going up in positive 4. 8, I'm going up in 8. Notice how the minus 5 is whatever would come in front. The minus 6 is what would go in front. The positive 75 is what would go in front. Okay, let's have a look at writing down the formula. So formula means the exact same as what is the rule, what is the equation. So that's telling me that's term 1, term 2, term 3, term 4. So how do I get from 11 to 15? Oh, I'm adding 4. 15 to 19, I'm adding 4. 19 to 23, I'm adding 4. I take that number and I stick it to an n. Then I ask myself, what would come before 11? I had to work backwards. And that would be a positive 7. So that is what would come before. Okay, next question. I'm moving on to question J. What is the y-intercept of the line y equals 3x minus 7? So this is what an equation looks like because it's got an equal sign. Okay. The y-intercept is the number that's flying solo. The number that has nothing else connected to it. If you notice, the 3 is connected to the x because it's being multiplied. But if you notice, this minus 7 is flying solo. And that's your y-intercept. It is minus 7. And if you're not sure what the y-intercept looks like on a graph, it is wherever the line cuts through here. So if it was at minus 7, it means the graph would have cut through this line over here somewhere. Either going this way or this way, we don't know. But it would have cut through this line over here. That's what the y-intercept is. Next thing, what is the gradient? And notice, sorry, how I've taken the minus along for the ride. That's very important. You can't just forget about it. What is the gradient of the line y equals 10 minus 2 over 3x? Now, if you look at that, you should have a look and see, oh, what's flying solo? The 10. So that's definitely not my that's definitely not my gradient. Your gradient is what is ever in front of your x. And in this situation, it is minus 2 over 3. Notice how I take the minus along to the right. So the gradient is just whatever is in front of the x. So if we have to look back at this example over here, my gradient would be the number in front of the x, which is 3. So my gradient on this example would have been 3, because it's in front of the x. They obviously didn't ask you that, I'm just telling you. The y-intercept here would have been whatever number is flying solo. And if you have a look, 10 is flying solo. So that would have been my y-intercept if they asked me. Okay. How do you calculate the gradient of a line? Well, we know the gradient has got to do with the steepness. So that is our rise over our run. Okay, next one. What is the y-intercept of a graph? Now, as I mentioned, the y-intercept is wherever the line crosses the y-axis. That's what I'm going to write down. Okay, the y-intercept, it is where the line crosses the y-axis. Okay, next one. Next one. 3 vertices. So vertices is just a fancy word for like the corners. 3 vertices of a square are at -2 and 3, 3 and 3, and 3 and -2. What is the coordinate of the fourth vertex? Now I'm very much a visual person, so I actually need to see this. I want to see. So what I did was I drew myself a little axis, and if I have to plot this, okay, we at -2 and 3, so x is -2, y is 3. X is 3, y is 3. X is 3, y is -2. So I know that a square has got the same length and it's got the same height. So if I'm going from -2 to 3, I'm jumping 1, 2, 3, 4, 5 spots. So I know I would need to jump from here 1, 2, 3, 4, 5 spots. And I'll draw my little dot over there. So those coordinates will be -2 and -2. So I just jumped my 5. So I looked here and I went, oh, 1, 2, 3, 4, 5. And I just count the same distance over here. Okay, so this coordinate would be -2, -2. Okay, question O. What is the equation of a graph with a gradient 6 and a y-intercept of -4? Now I know from these questions that my gradient has to be stuck to an x, and my my y-intercept is just flying solo. So, if my gradient is 6, I know that's automatically going to have an x afterwards. Because our rule with the gradient is it needs to be attached to the x. Okay? Then my y-intercept is -4, and that just flies solo. Now, to make this an equation, I have to just add on y equals. So notice, my gradient is in front of the x, and my y-intercept is flying solo. Explain why the sequence is not a linear pattern. Now, linear is all of these, where we're going up or down the same amount. So here, we were, going up in 8s. Here, we were going up in 4s. Here, we were going down in 15. Here, we were going up in 4s. Now, if we have a look over here, for me to get from 1 to 2, I have to add 1. For me to get from 2 to 4, I have to add 2. For me to get from 4 to 8, I have to add 4. A linear sequence needs to have the same constant difference every time. So that is why this is not linear. So I would say the sequence is not linear because it does not have the same constant difference. Okay? And constant difference is just a fancy word for what are we going up in. This is the constant. It's the constant change or the constant difference between the numbers. Okay. I'm going to move on because we've still got some achieved. We've actually got some merits here too. So I might as well just go through everything while I'm here. Okay. Again, I'm not expecting you to follow along. If you are working on other things in the Cream book, that is absolutely fine. But this is for people who want to follow along. Now, Consider the following pattern. So, pattern number 1 would be this, over here. And they're saying that pattern number 1 has got 6 lines. So let me just check. 1, 2, 3, 4, 5, 6. Check. So let me count how many pattern number 2 has. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10. Now pattern number 3 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. They don't give me pattern number 4, but I'm pretty sure I can figure it out. Because if I just ask myself, how did I get from 6 to 10? Oh, I added 4. How did I get from 10 to 14? Oh, I added 4. So guess what I'm going to do? I'm going to add 4, and that is going to give me 18. Now they're asking, write the formula for the number of lines. I know how to do this because we did this over here. These are the formulas. And interestingly enough, if you notice, this is worth an achieved. And it's the same question, but look at what it's worth. This is worth a merit. Okay? So, if you have a look, write the formula for the number of lines. So, what am I going up in? 4. What am I sticking to that number immediately? N. And then what would come before the 6? That would be a positive 2. Okay, moving on. How many lines will be in pattern 12? Now, if you, once again, I'm going to look at this page. If you could do the first 3 terms, that means you did what is term 1 or pattern 1. What is term 2 and pattern 2? Term 3 and pattern 3. It is the exact same skill. All we're going to do is we're going to plug in a 12 because they want to know what's pattern 12. In the previous questions they asked what's the value of term 1 to 3, or like the first 3 terms. So we found term 1, we found term 2, and we found term 3. Now they just want term 12. So I'm just going to go 4, plug in my 12, plus 2. You just plug it in. Take out the letter, put in the number. 4 times 12 plus 2 equals 50. Easy peasy. You just take out the letter, put in the number. Okay, next question. Which pattern will have 230 lines? So they now want to know what this is going to be. They want to know, they're giving us this answer, and they're asking us to figure out what this number would be. So what I'm going to do is I'm going to write this out, and they want to know which one's going to have 230 lines. Now, using our basic algebra knowledge of solving, and this would be an achieved in an algebra test, I want to get the letter by itself. I want that by itself. So I've got to get rid of everything cramping ends style. Okay? So remember, we've got to get rid of the 4 and the 2. Which one do we do first? We're going to do whatever is not attached to the n. If you have to think about taking something away, if I was holding on to n, and this was 4, and we had 2 that was just chilling over here, which one's easier to take? This one is easier to take. So we're going to get rid of the 2 that's flying solo first. So how do I get rid of plus 2? Oh, I minus 2. I do the opposite. If I do something to the left of an equal sign, I have to do it to the right, because we've got to keep it balanced. So 2 minus 2 is 0. Perfect. What's left over? Okay, I've got my 4n is still here. And 230 minus 2 is 228. Now I've got a 4 connected to my n. I still need to get rid of the 4 because they're not asking what's the value of 4n. They want to know what's n. What pattern number is this? So you still need that n by itself. So I've got to get rid of the 4. And how do I do this? Well, what I do is I ask myself, What is happening between these two? When they're squished together, it means multiply. When they're squished together, it means multiply. So I'm going to do the opposite. Opposite of multiply, which is divide. So if I divide this side by 4, remember, as I did over here, if I do something to one side of the equal sign, I have to do it to the other side of the equal sign. So I'm going to divide that by 4. So 4 divided by 4 is 1. Amazing, because I just want 1 in. If I go 228 divided by 4, that gives me 57. So pattern 57 will have 230 lines. I'm not going to do the E question because I'm going to just do a separate video just on the E questions for this, if you want to go and look at it. I'm going to move on here to this. Okay. Which is, notice, the exact same as this one. The same questions. Yeah? So I'm actually not going to do these. Should I? Oh, let me do them quickly. So, we've got 2 squares over here. I'm actually just going to hold on. I'm going to skip that because it's similar. And I'm just going to go to a 4 because I don't want to repeat the same skills. Draw the following lines on the set of axes below. So here's my axis, and here's my equations. So let's start with the first one. I'm going to start with A. You've got 2 options. Either you draw yourself a little table, or this is the other option. I know that this number is where the line will cross over here. So I know this graph is crossing at that point over there. Because the y-intercept, that is the y-intercept. Remember, whatever's flying solo, without any letters attached, that is where it crosses this line. Now, from there, I can use my gradient, which I know is rise over run, and I can just count. So what's my rise? My rise is 4. So I just go 1, 2, 3, 4. And my run is 3. So I'm going to go 1, 2, 3. And I'm going to draw that dot, and I'm going to connect the 2 lines, like so. And that is A. So all I did was, I used my y-intercept as my starting point. Then I went ahead and I used my gradient, which was 1, 2, 3, 4 was my rise, and 1, 2, 3 was my run. So all I did. So all I needed was 2 points, and that's what I did. Okay, next one. Y equals minus 3x plus 4. Now we know my rise over run is my gradient, and you'll notice this isn't a fraction. But our knowledge about minus 3, or any number, like 2, 7, 10, it's all over 1. It always is. We just don't write it like that because mathematicians are lazy sometimes, and that's okay. Okay? So, if we have a look at this, that's my rise, and that's my run. So, first things first, where are we flying solo? We're flying solo here, which means I can go and find it on this axis over there. And I'm going to draw a little point. Point. Check, I've done that. Now, using that point, I'm going to do my rise over run. Now, notice how my rise is negative. And we know if my rise is negative, I'm counting down. I'm going down 3, 1, 2, 3. And my run is 1. So I'm going to go 1. There is my second point. So I've got 2 points. And all I need to do is connect them like so. And that is B. This part is probably the easiest. Like the starting point is easiest. It's because all you need to do is find that on the graph. If that wasn't there, it means the graph would be going through the origin, which would be 0, 0. So you could start at the origin. Because sometimes it doesn't necessarily always mean it's going to be going through this line. Sometimes it's going to go through over here at 0. And we don't write plus 0. So imagine we had y equals 4 over 3x. That just means we don't go through this line, we're going through 0. So my point would be there, and I would go from there using my rise and run. Okay, next one is a special kind. This one over here, all it means is find 1 on the y-axis. So where is my y-axis? Here. Where is 1? Here. And all I'm going to do is I'm going to draw a line going through my y-axis like that. All I did was I found 1 on my y-axis and drew a line through my y-axis. That's a very easy achieved. Very easy achieved. Next one, this is now not y anymore, now it's x. X is equal to -1. So find -1 on the x-axis, which is here, and draw a line through the x-axis. Well, sure, I can do that. That's easy. Boing. Done. So there is that. My x equals 1. Notice how it goes through the x-axis. And here is my y-axis. And that is the line I drew for y equals 1. Okay, question 5. We're having a look at a graph of somebody walking. So if we look here, this is obviously going up in time. So 5, 10, 15, 20. And here we're going up in kilometers. So 1 kilometer, 2 kilometers, 3 kilometers, 4 kilometers. For how many minutes did Manish stop? So if he stopped, that means he wouldn't be traveling. So if you notice here, he's not traveling. He's staying at 3. So if he stopped from 30 to 40, that means he stopped for 10 minutes. Okay, he stopped over here. If we look down here, that goes down to 30 and to 40. So he stops for 10 minutes. What speed was Manish walking for the first 30 minutes? So from here to here, they will know their speed. And all you do here is you calculate the gradient. So we're just trying to figure out the rise of a run. But they want it in kilometers per hour. So let's think about this logically. Okay, let's just work through it first. He goes 1 kilometer in 10 minutes. He does 2 kilometers in 20 minutes. He does 3 kilometers in 30 minutes. So do you notice how he does 1 kilometer per 10 minutes? So if he does, let's imagine this wasn't like this. Let's imagine it just kept going. If he had done 40 minutes, he would have done 4 kilometers. If he would have done 50 minutes, he would have done 5 kilometers. If he did 60 minutes, which is 1 hour, he would have done 6 kilometers. So that's how fast he was going. He was going 6 kilometers per hour. So all I did was I looked, he went 1 kilometer in 10 minutes, 2 kilometers in 20 minutes, 3 kilometers in 30 minutes. So if I just kept that same pattern going, I can figure out how much he's doing in an hour. How can we tell from the graph that Manish was walking slower after he stopped for a break than before his break? Well, first, the really obvious thing is you can notice this line is steeper compared to that line. Look at how steep that line is. This line's a little bit more flat, and this one is more steep. So that's from the visual aspect. I can just see. I know that the steeper something is, if this was steeper, he would have been walking a lot faster, because he would have been covering more ground in less time. But if you look here, from 40 minutes to 50 minutes, he only did what? Half a kilometer? So from 3, he went to 3.5. He did half a kilometer. in 10 minutes. Over here, he was doing a full kilometer in 10 minutes. He was doing half. So that's the other way you can have a look. You can look at the numbers. Okay, I'm going to do this one quickly. Question 6. Below is a graph showing the distance traveled in a running race between Neil and John. Who won the 110 meter race? Well, let's have a look. Where's 110 on this graph? I use my ruler. There's 100, there's 110. Who got there first? This person. Was it this person? Yeah, this person got to 110 first. John, at this time, oh, he's between 80 and 90. So Neil won. Again, I'm not going to do the excellence question. Last little bit. Question 7, last one, then we're finished. Okay? Write the equations of the lines below. Above. So I know I've got to have y equals something x something. I know that. So let's look at A. Okay, this is the easiest one to do. What's flying solo? What's by itself? Where it cuts through this line, which is over there. So that can be the first thing I pop in. Because we know that the y-intercept, wherever the line cuts through this axis, is the last little bit. Now we can work on our gradient. So let me do my gradient. I need 2 points. Let's do that point. Let's do that point. And let me calculate my rise over run. So my rise is 1, 2, 3. My rise is 3. Let me just pop that there for now. And my run is 1, 2, 3, 4. So y equals 3 over 4. What always has to get stuck to my gradient? X. And I'm done. Finitos. Okay, remember my gradient? I did my rise over my run, which was 3 over 4. And that goes in front. Well, whatever's flying solo is my y-intercept, and that's that over there. Okay, question B, same thing. Let's find the y-intercept. The whatever's flying solo, which will be that over there, positive 4. I know I need a y equals with something x. Let's find my gradient. So I'm going to use that point. I'm going to use that point. And my rise, I'm going down. So it's minus 2. And my run is 1. And I know that minus 2 over 1 is just minus 2. So that is my gradient, minus 2. Done. So my equation is minus 2x plus 4. Last one, C. This is my special one. Okay? This line is just horizontal. Now, which axis is it cutting through? My y-axis. That's how I know I put down a y. Wherever this line is going through, that's what you put down. And where is it cutting through? At 2. And that's all I got to put down. If I had a line, let me draw another one. If I had a line over here like this, let's say that was a line. First thing I ask myself is, which axis is the line cutting through? It is cutting through this x-axis. So I would write down x equals, and at what number is it cutting through? It is cutting at 5. Okay. So with that being done, there's still a little bit more. I'm not going to go through that. I will be making a video on all the E questions. If you've got any other questions here, please just let me know. And for the rest of you, you can start packing up.